Okay. Lab 6 is all about plotting the graph. So as you have seen in your previous labs, we did a histogram, parallel box, scatter plot like that. We'll be doing graph here also, but we'll be doing only one graph that is called as normal probability plot, or else we call them as QQ plot. In short, we call the graph as QQ plot, or else it will be called as normal probability plot. Okay, so going straight to assignment, 1A is just plotting the histogram and then the QQ plot also. As always, I will show you how to do this for one variable, and you must do for the remaining variables, and make sure it is under numeric continuous. Okay, you cannot do it for the categorical variables. You are supposed to do a plot only for the numeric continuous variables. Okay, and then 1B is nothing but you will get some variables which are not normally distributed. Okay, like in 1A you will be determining whether the variable is normally distributed or not. So you might get a variable which are not normally distributed. So you'll be taking any one of those and then transforming it to make it a normally distributed variable. So for example, height is not normally distributed, then you are going to apply some formula, make some changes, and then make it back to, then you must make it look like a normally distributed graph. So that is what we do in one. You can do for one variable, that is enough. You don't have to do for more than one. And 1C is nothing but you'll be creating a table, and then you just have to summarize A and B. Okay, like just have to list out the variables name, and you must mention whether the respective variable is normally distributed or not. And also, there'll be one more column attached, meaning it as a transformation, and then you must mention to which variables you have applied the transformation. And remember, transformation can be done in two methods. One is by using a logarithmic function, okay, and then by a square root transformation. So today in this lab, we'll be learning about the square root transformation, okay? And then the part 2 is quite tricky. So what you have to do is, like you did in the last lab, you will be comparing the probability of the variables. So you have two methods to do that. One is by determining the true probability, and in method 2 you will carry out the simulation and then find out the P of x value, right? So this is what we'll be doing today. And then for the part 2, you have to compare both the answers. You must get it similar. Okay? So that is what we'll be doing today. We will learn how to do the 1A first. Open your GMP. So from here, you have to open the subset of small term. Okay? Open subset of small term. It should be subset of small term, not the subset. Okay. Subset of small term. Now, you must plot a QQ plot. For that, go to analyze, then distribution. Okay, to get a QQ plot, you first have to do a histogram. So you all know how to obtain the histogram graph. Okay, so go to analyze, distribution, and then you are supposed to select only the numeric continuous variable, not the categorical. You must select only the numeric continuous variable. Okay, let me choose height, Y column, okay. You have to select one variable, place it in Y column, and then click on OK. Fine, you get this. This is your histogram. Okay. So now you must obtain a QQ plot from this. How do you do it? You have to click on the red triangle here. Okay. Click on the red triangle here. After that, you have a normal quantile plot here. You have the option called as normal quantile plot. Click on that. You get this. Okay. But still, you have one more step to do to get the exact QQ plot. For that, go to continuous fit and you have fit normal. Okay. First, what you have to do is click on the red triangle, select this normal quantile plot. After doing it, go back to the red triangle again and then choose the continuous fit, and then you have to select the fit normal. After doing that, you get a graph like this. Okay. So let me make it horizontal. I hope you can see the screen. Okay. See, as you can see, there is a graph. This is your QQ plot, also called as normal quantile plot. Now, how do I determine whether this variable is normally distributed or not? To check that, you have two options. One is that the data, the black dots, whichever you see, those are called as data. Okay. So these data must be on the red line. Okay. It must be on the red line or close to each other. That is one way to find out. The other way is the bell-shaped curve. This curve we call it as bell-shaped curve. And this curve should include all the box plots. But as you can see clearly, the one data is being out of the line. Okay. So you must to decide whether a variable is normally distributed or not. If a variable is normally distributed, then you get all these boxes inside the line. Okay. So the bell-shaped curve will have the complete boxes inside. There will be nothing outside the line. And also, here also, the data will be exactly on the red line and they will be close to each other. Okay, but as you can see, height is not normally distributed because the boxes are outside the line. Okay, one might be excused, one box, if it is out of the line, then it might be excused. But as you can see, there are some boxes, few boxes, which are outside the line. So we say that this height variable is not normally distributed. Okay. So I will close this and let me go and show you which variable looks like normally distributed. And let me check for weight. Click on Y column. Okay. Then go here, normal quantile plot. I'm just repeating the procedure, so I'm going fast. That's normal, right? Then we will continuous fit normal. Display option horizontally. As you can still see, the weight is also not normally distributed. When you see the bell-shaped curve, the boxes are being out of the line. Okay. one box can be excused, but if there are few boxes but there are actually all the boxes which are outside the well-shaped curve. So we say this is not normally distributed. Likewise, you will have to check for all the variables, for all the numeric continuous variables. Okay? And then first A can be done like this. And then what about 1B? I said you need to apply a transformation for whichever variable which is not normally distributed. I gave you two examples which was not normally distributed. Okay? So I will apply transformation for any of these two variables. Let me see, I will apply transformation for height. Then let me go to analyze. Okay. So to apply the transformation, you actually have to create a new column. Okay. How do you create a new column? Can you see here the space? Just have to double click on the heading inside this column. I will show you again. Just double click on the column. Okay. You get a new column. Then I will rename it as transformation. So how do I rename it? Right click, go to column info, right click, go to column info, and let me rename it as transformation. Okay. Now, after doing this, I will have to apply a formula, right? Because I told you there are two methods to obtain a transformation. That is by logarithmic function and then is using a square root formula. So for this class, we will be doing square root formula, and hence I need to apply a formula. That go to column properties, formula, column properties, formula, edit formula. Okay. Column properties, formula, edit formula. I want to apply a square root. Okay. Where can you see a square root here? This is your square root. It clearly displays that it is a root. Okay. You have to select this. Can you see the mathematical expressions on the top? You have to choose this from the whole thing. Okay, let me select it. Now, I need to apply a square root for which variable? For height, right? But I will select this column. I need to select the variable whichever I am applying a square root. I am applying a square root for the variable which is not normally distributed, that is height, right? The square root of height, and now you have to fill this. As I said here, it is a square root. So when I say square root, n value will be equal to 2. Okay, n is equal to 2, which says it is a square root. Square is nothing but 2. When you say cubic or cubic root, then n value will be equal to 3. Fine. So after applying the formula, go to apply, and then okay. So are you all clear with this, or do you want me to repeat any steps? You can unmute yourself and then you can tell me where I was stuck. Okay. Then again apply. Okay. So you get a new column, that is transformation of height. So you are applying a transformation for this variable. So once you are done with this, again let me check whether it is normally distributed. No. So for that, go to distribution. You have to choose this. Okay. The new column. You have to plot a graph for the new column. Transformation by, okay, place it in a by column. Then, okay, you get this. How do you get a normal pointer plot? Click on the red triangle, choose the normal pointer plot. Right. still you have one more step, that is go back to the red triangle, and then you have to give a continuous fit normal, continuous and fit normal, make it horizontal. So go to this option, horizontal layout. Okay, you get this. As you can see, this is not as been distributed normally, but it has to be distributed normally. Let me see what mistakes we have done. Okay, column edit formula, we applied a square root of height because it is normally distributed. Apply OK. So if everything was correct, okay, everything was correct, and then go to analyze, distribution, Y column, click OK. But if you still see that it is not normally distributed, okay, if you still see it is not normally distributed, then you can choose the other variables. Okay, if you still get it is not normally distributed after applying the transformation also, you can say that it cannot be made as a normally distributed variable. So you can choose some other variable. Let me select this column. Okay, now go to analyze distribution. Let me choose, okay, salary. Over here from the pointer plot, so continuous fit normal. Horizontal. Okay, so as you can see, the boxes have been out of the curve, and also the data are not being on the red line. Okay, so any of these two can be true. Like suppose if you get data which is plotted on the red line, if all the data are plotted on the red line, and if you get a same graph, then you can still say this is normally distributed. Okay, but as you can see, the data in the black dots are not on the red line. Okay, so I say this value is not normally distributed. Now what should I do? I have to apply a transformation. For that, I need to create a new column of the column info, then change as transformation, go to column properties, formula, edit formula, go to square root. Okay, you need to select salary. So place the salary here. Now let me see, n is equal to 2, right? Okay, apply. Okay, and click OK here. So that's the new column. Let me plot a graph for that. So that, go to distribution, this transformation, Y column. Okay, right triangle, normal quantile plot, and then put normal. Okay, display option, horizontal layout. As you can see, there is a difference when you compare the last graph of the salary. Okay, the dots were being placed here, but as you can see, most of the black dots are being on the red line. So we say that this salary is now normally distributed after the transformation. Okay, so this is how you conclude whether a variable is normally distributed or not. So you just have to check whether the black dots, most of the black dots, has to be on the red line. You don't have to like all the dots on the red line, but most of them have to be close to each other and also on the red line. And coming to this, the boxes should be inside the curve. Okay, most of the boxes should be inside the curve. If not, you can proceed with the black dot. Okay. So after this.
So do we have to do that for all of the numeric continuous to see which ones are or do become normally distributed?
Yes. For the first thing, you have to do for all the numeric continuous variables. And if you want, like coming to the transformation part, you can do any for any one variable. You don't have to do for all the variables. You can do any for any one variable. But you have to check. Like I checked for height, and it was not normally distributed after applying transformation also, but it was normally distributed for the salary, right? So you have to check like that. And then if you get it has been normally distributed for salary, then you can stop there. You can just do for one variable. You don't have to do for all the variables. I am talking only about part 1B, okay? And then coming to 1C, as I said you have to create a table like this, which has a column variable, and then you have to mention whether the variable is normally distributed or not, and then transformation is made. Okay, so you have to mention the variable name. I did not mention all the variables here, but just as an example, let me say height. Height, as we saw, it was not normally distributed. So I write it is no. Okay. Did you apply transformation? Yes, I did apply the transformation, but still the answer is no. Coming to weight. Okay. You have to tell me whether it is normally distributed or not. And coming to salary. Yes. Did you apply a transformation? Yes. Okay. Like this, you have to create a column and then mention the you just have to fill the column. Okay. So after creating the table. So this was about part 1. So is everything clear till now? Or if you want me to repeat, I can.
So do you want us to take like screen captures of the histograms and keyplots and put them on there, or do we just need to use the table?
No, you have to also paste the graph. Okay. For example, I say 1A. Okay. You need to paste the whole graph. Make sure you paste the normal quantile and the spreadsheet curve. Okay, that is enough. You don't have to paste all the data, but you can paste only this. I'll show. Quantile plot, and make sure it is in horizontal. Okay, so I can make it more clear. Okay, so this is not normally distributed, but assume that it is normally distributed and then you can paste it. But if it is not normally distributed also, you have to paste the graph for part 1A. So how do you copy it? Just go to toolbar to selection. I need only this, okay? The one here and also this, right? So for that what we do is, you just have to click on the space here. Okay, make sure you click on this space here. Just click on this and yeah, it is selected. You don't have to paste all the whole thing, okay? You just have to place the normal quantile and the bell-shaped graph. Control C, go to word 5. That was for ID. Okay? Yeah, Control V. And make sure you change it to the picture format. Okay? That's it. This is how you copy and paste for all the variables. Make sure you do it for all the variables. Okay? And also after applying transformation for part 1B, you have to paste the graph like this. Okay? Only these two graphs are in. Once it is done, so any other doubts? Okay, then we will move to part 3. So this question says that you need to choose a variable that you found to be normally distributed. Okay, if you find that it was normally distributed, then choose a variable which was normally distributed, compute the mean and standard deviation. Okay, you need to find what is the mean and standard deviation for that, and then you have to write down the result. Okay, and then you need to compute the x1 and x2 values. You have to determine what is x1 and x2 values, and then that is one part. Okay, so determining x1 and x2 values by plotting a graph is one method, and also you need to find the same x1 and x2 values by doing a 10,000, by running a 10,000 simulation. You have to do it again. Okay, so you will have two methods now. You have to compare both the results. You have to get it similar, not exact, but the solution should look like C. Okay, so this is what we will do for the part 2. Now let's close this. Going back to the subset, I will delete this. Okay. Now I need to select a variable which was normally distributed, and then I need to find what is a mean and standard deviation for that. For example, go here, distribution, let me just hide. Actually, I've set the normal. Okay. So my assuming that this is normally distributed. As you can see, most of the data are being on grid line, and as I said to you, you can just check for any one. So even though the boxes are not being inside the curve shape, but the data here is on the grid line, right? So I say that height is normally distributed. And also I remember saying it was not normally distributed in the first part, but you can make it normally distributed if it looks similar. If the data are being like this, you can make it normally distributed. Okay, you can just write that height was normally distributed. I can change here. I can write that if it was normally distributed, but because as you see, the data, most of the black dots are being on the red line. Okay, so yeah, after this, after doing all this, okay, so this height is now a normally distributed variable. So what should I do next? I need to find out what is mean and standard deviation. Okay, so you get the mean and standard deviation in 7 statistics. So what is the mean value? It is 66.21. Okay, the mean value is 66.21 and standard deviation is 3.9. Okay, let me go and enter the values here. So what was my mean value? 66.21. So I write 66.21 and what was standard deviation was 3.9. Okay, mean and standard deviation 3.9. 3.9. Okay. Now, there was a formula mentioned in your assignment. To find x1 and x2, this was the formula. x1 is equal to x bar negative 1.5 times s. Okay. So x bar is nothing but your mean. S is nothing but the standard deviation. So you have the values for both. X bar is also there, S is also there. What you have to do is just have to calculate x1 is equal to what was x bar. X bar is 56.21. So I write 56.21 negative 1.5 times standard deviation. Standard deviation is 3.9. Okay. So now you have to compute the result. First, let me do for 1.5 times 3.9. It is 5.85. So you get 66.21 minus 5. Okay. Is equal to what? 21 negative 5.85. You get 60.36. Okay. So you found your x1 value. In a similar way, I will calculate for x2, which is equal to 66.21 negative 1.5 into 3.1.2. 1.2 times 3.9 equal to 66.21 times 4.68. 3.2 61.5. Okay, you got your x1 and x2 values. So you have any questions to you? You have to be careful while determining the x1 and x2 values. Okay, if you make a mistake in the starting, then you will get your answers wrong. Okay, and yeah, my mean and standard deviation is just for a height variable. You can choose any variable which is normally distributed. Okay, and your values x1 and x2 will definitely change. You don't have to worry about that because the variable which you took is different. And also, I chose height, and if you also choose height, you might not get the same result for x1 and x2 because my sample size will be different and your sample size will be different. Okay. So after determining x1 and x2, now you know what is x1 and x2. I need to find a probability value for this. So how do you find a probability value? Go to GMT and close this. Now I need to create a table. Okay, file, new data table. Now I will give 2 columns. Okay, so just right click on this column info, rename it as X because we will enter the x1 and x2 values, so rename it as X. Just click OK, and then you need to give x1 then x2 values. What are x1 and x2 values? I will write. You need to enter the values for x1 and x2. What were the values which I got? Was 60.36, 61.53. Okay? Your value for x1 is equal to 60.36 and value for x2 will be equal to 61.53. I need to enter these values in this one. Okay? x1 value was 60.36, x2 is 61.53. After doing this, create one more column. That will be your P of x. Rename it as P of x. Now, you need to apply a formula. Because you are going to compute it, you need to apply a formula for column 2. So, go to formula, edit formula, then choose as probability. Okay? Select probability because you are finding a probability for a particular number. You have a data there. So, choose as probability. Here, you will be choosing normally distribution. Okay? Normal distribution. Probability and then normal distribution. So, after doing this, you need to enter a value to find normal distribution. It must take value for mean and standard deviation. But as you can see, there is only one space. Okay? There is only one space. So, for that, what do I do? Can you see the heading of the insert option? Okay? You have to go and select that. Insert. Again, you get a mean there. You got the mean. You need to enter standard deviation also. So, click it again. You need to click it twice. Okay? You get mean and standard deviation. Now you can enter the value. So, for F, you need to choose this column. Okay, for X, select this column. And for mean, you know the value for mean. What was the value which you got from the graph? It was 66.21. Okay, 66.21, and then standard deviation is 3.9. Okay, after doing this, click on apply. And F, okay, move here, here, and then create a formula, enter edit formula, probability, normal distribution, then click on this up arrow twice, and you need to mention the x value. Click on this and drop it here. That the x value, mean value was 66.21. 66.21. Standard deviation was 3.9. Apply. Okay. Again. Okay. Fine. We don't get the value here because you did not enter the value. So after applying the formula, and then you can enter the value in the x column. So x value will be, x1 value is 60.36. Enter. And the other one is 61.56. Enter. Fine. You must get x1 and x2 values. Okay. So, after you get these two values, you have to paste this also. Use the snipping tool, go to new, and then just grab this, copy it, go to word file. So for the part 1, you calculated both x1, x2, paste it here. Okay. Now, what was the probability of x1? What was the probability of x1? Is equal to 0.0668. Okay. And probability of x probability of x2 was 0.1150. Where did I get these values? It's here. Okay. x1, probability of x1 is this, probability of x2 is this. Now, what is my final answer? It should be like this. Probability of x, I need to find a probability of x, which should lie between x1 and less than x2. Okay, that will be, your answer must be the greatest value. Okay, what is your greatest value among these two? It is 0.1150. So you have to choose the greater value. Okay, now you got the final result as 0.1150. This is your probability for variable x. Okay, this was the result for the method 1. Now we will calculate for method 2. Okay, for method 2 also your mean and standard deviation will be same. Method 2, your mean and standard deviation will be same, and also your x1 and x2, because the formula are same. Okay, for x1 and x2 we are doing a simulation, right? We are carrying out a simulation for 10,000 rows. Okay, and then from that you will find out what is x1 and x2. So for that, to carry out the simulation, go here, file, new data table. Okay, to carry out the simulation, you need to create a table. So go here, maximize this. Now, I need to enter a formula for column. Okay, I will rename it as x because I need x1 and x2 values. I will rename it as x, and then I need to apply a formula. Go to formula, edit formula, random, because you are doing for 10,000 simulations and the data will be selected randomly. So click on random and then random normal. Okay, since we are doing normal distribution, random normal. As you can see, there is only mean, right? So you need to enter values of mean and standard deviation. For that, go here, expand it once, because if you get for mean and standard deviation, it is done. Now I will enter the mean values, which was 66.21, okay, sigma standard deviation will be 3.9, apply, okay. Okay, after applying the formula, just click on OK. Now your column is ready. You just have to add a row. So add rows as 10,000. Enter, you get these values. Okay, you get all the x values. Now, what you have to do is you need to sort it out. For that, why do you need to sort out? Is because you need to find the x1 and x2 values. Okay. So for that, go to table, sort, and x in the bisection, just like this. Choose x, and then click on by, and then click as okay. You get a new column. From here, okay, how do you choose the x values here? By using the data which you have already got in the method 1. You got your x1 value as 60.36 and x2 value as 61.53, right? Okay, so from method 1, we get don't have to calculate it again. Okay, this is your x1 and x2 value. So, what you have to do is, you have to go to the new table which you have started. Okay, now you need to search a data from 60 to 61. Okay, search for 60 here in the X column. I got it. This is your 60, right? You got 60 here, but you must select the above column. Okay? You must select the above data, above row. The top one, the one which is on the top of 60. Okay? Once you get this, what we are doing is we are obtaining a result between these two. Okay? We are getting a data from 60 to 61.53. For that, we need to search for 60. So I searched it for 60. I got a value, but you need to select a value above that. Okay, to make it more accurate, you need to select a value above the 60, and then you get this, right? So what you have to do is again go to snipping tool. You need to choose that. Okay, the starting simulation number is enough. I just need the starting simulation number. Okay, this is enough actually. Copy and paste it here. Okay, and now again I have to search for x2, right? Till 61, so I need to search for x2. Go here and search for 61.53. You get 61.53 here in 172 column. Okay, you just have to crop this. You get 61.53 here. Go here. You can also choose the row below that, or else you can select that also because it is maximum. Anyway, it is maximum. So you can just choose that. Copy. Copy this. And You can paste it here. Okay. Now you just have to do a calculation, further calculation. How do you do? Now you need to find a probability now. What is P of x1? P of x1 is equal to write the simulation number. So simulation number for P of x1 was 60, right? So probability of 60.36. Okay. Probability for 60.36. You can search for 60.36, or if you search for 60, that is also somewhat correct, because 60 and 60.36 is not much difference. Okay. And then equal to, what is the probability of 60.36? Just write the simulation number divided by 1000. Okay, because we carried out for 10,000 simulation, so you need to divide it by 10,000, equal to 0.0558. If you divide it by 10,000, you get this value. You can do it by using calculator, and then you need to find out your x2. Your P of x2 value is equal to P of 61.53, which is equal to 1174 divided by 10,000 is equal to what? Will be 1174. Okay. Now what was your Your value for this was 0.1150, and here it was 0.1174. As you can see, there is a value similar, not exact, but they are similar. Okay, so that is how we conclude. Now, how do I write the conclusion? Here of this. Okay. Is equal to 0.1174. How did I get 0.1174? The greater number. Okay. Just have to choose the greater number, and also you can compare the P of x1 values also. Okay. You can compare here. This was in the method 1. This was in method 2. P of x1 was 0.06 and this is 0.05, similar. And P of x2 is 0.1150. This is 0.1174. This is also similar. Further, you can just find out the probability exact value is found by subtracting these two values, but still you can just take the greater value. Instead of subtracting, you can take the greater value, or if you subtract also, you get a similar result. So this was your last step. So is there any steps you want me to repeat? So if you want to subtract it, then also you can do. There is assignment PDF, generally I say it is just, it contains how you proceed with your, how to proceed with your assignment. So that is, I did it in the spring semester, so you can follow that because syllabus is free. You can follow that also. I mean, there is a format on how to copy and paste and how your assignment should look. So if you want to make it, if you want to subtract it, you get a more accurate result, I say. So I can separate these two values, 1174, negative 0.0558, which is equal to 0.1174 negative 0.0558 is equal to 0.061, right? And now again, I can do it here also. I can subtract that. So x1 0.668. So calculator 0.1150 negative 0.0668. You get 0.0482, which is approximately, we can see 0.05, because 4 8 is nothing but near to 50. So we say it is 0.05 and 0.05, 0.06. Not much a difference. So you can do like this, or if you just take the greater number, that is also fine. Okay. So this was your lab sim. Any doubt till now?